Okay, I was making sure my volume was on. So, you guys are going to do 4.4 today. It is talking about how we can tell if triangles are congruent. So we have some very specific theorems and postulates that we use for this. I'm trying to get in a little bit clearer. The good news is you guys have the handout, so I'm trying to just get it as clear as possible. I think that's as good as it's going to get. Okay. So, we are only dealing with side, 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 which we can abbreviate as SSS, and we are dealing with side, angle, side congruence in 4.4. So the first one is side, side, side. You can say that two triangles are congruent. So triangle ABC is congruent to triangle ZXY because of side, side, side. They have three sides that are respectively congruent, as in like not all of them are the same, but these two are the same, these two are the same, and these two are the same. Now, up until today, you guys have been able to label a triangle pretty much in any order as long as it's an order that you can draw it. So we could have called this ABC, we could have called this BCA, we could have called this ACB, and so on. With congruence, they have to go in the same order. So notice when I say that triangle ABC is congruent to ZXY, I am telling you the sides that are congruent. I should be able to look at this notation and know which sides are congruent. So when I said AB and ZX, those were both the one tick side. Then when I said BC and XY, those were both the two tick side. So you have to be very specific now when you label label congruent triangles when we're talking about congruence with side, side, side. Okay. The next postulate that we're going to talk about today is side, angle, side. The thing that's important about side, angle, side is the angle that we are talking about has to be the angle that's in between the two congruent sides. We're going to call this the included angle. Okay, the included angle is the angle between two congruent sides. Okay, so notice when we talk about triangle ABC being congruent to FDE, again, my sides, I went one tick, two tick, and the angle between those two, it's pretty much, if you draw the angle, those two sides, that's the included angle. It's between those two congruent sides. Okay, has to be that one. So example one, side, side, side on the coordinate plane. I give you this, guys. You're not always going to have a drawing. They are usually just going to give you ordered pairs. But they would like us to determine that triangle QRS is congruent to triangle EFG, and they give us all of the ordered pairs. They want us to do it by side, 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 which means I need to know which sides are congruent, and if they are congruent, what that length is. So we're going to default back to the distance formula, because the distance formula will tell me the length of these sides. Okay, so let's look at side QR. Let's find that one, because that one should be congruent to EF. So I'm going to go ahead and do the distance formula. So the distance formula is the square root of the second x, so whether you choose Q or R, it doesn't matter. I'm going to do Q first. So 5, oops, I'm doing y's first. Let's start over. Let's do x's. 2 minus 5 squared plus, then your y's, 5 minus 3 squared. So if I do that, and I simplify it, 2 minus 5 is negative 3. Negative 3 squared is 9 plus 5 minus 3 is 2. 2 squared is 4. This gives me the square root of 13. Now, I recommend, guys, when you get these, just double check, because sometimes these radicals break down and we're not the best at seeing what they are. So if I put square root of 13 in my calculator, it comes out to be 3.60606 if I round it. It's really 0.55, but I'm going to leave it like that, okay? So then let's go try EF. So EF, I have my x's, so -4 minus a -1. Notice that I didn't forget the minus squared plus my y's, 2 minus 0 squared. And if I simplify that, -4, this becomes a plus. So this is really -4 plus 1, which is -3 squared, which is 9. 2 minus 0 is 2 squared, which is 4. And notice I'm going to get the same number. So we just found out that EF is congruent to QR. Okay. Now I'm going to go ahead and check the next ones. And if I look at the notation, the next one would be RS should be congruent to FG. So again, I'm going to go to the distance formula. And if I do RS, I have them right here. And I do my x's. So I have 5 minus 3 squared plus, and then I do my y's, 3 minus 1 squared. And if I simplify those, 5 minus 3 is 2, 2 squared is 4, plus 3 minus 1 is 2, 2 squared is 4. This gives me the square root of 8. And if I put that in, I get 2.828. And then I'm going to go ahead and do FG. FG is, if I do my x's, I have a -1 minus -3 squared. And then if I do my y's, I have 0 minus -2 squared. And of course I have those two minuses, so I'm going to do pluses. And if I simplify it, I get -1 plus 3, which is 2 squared, which is 4. And I have 0 plus 2, which is 2 squared, which is 4. And those sides come out to be the same. So we just found that RS was congruent to FG. And if you remember from our 4.12 notes, we have a postulate that says if we have two sides that are congruent, the third side is congruent. Okay, so we don't have to do the third side, just showing that these two are congruent and that these two are congruent is enough justification to say that triangle QRS is congruent to triangle EFG by side, side, side. Okay, so that's done. Our next example, determine which postulate can be used to prove that the triangles are congruent. I'm literally asking you to tell me side, 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 or side, angle, side. And if it's not possible to prove that they're congruent, right, not possible. So if we look at example A, I don't necessarily know side, angle, side. So the first thing you guys usually see is that you see this angle right here and you're like, oh yeah, side, angle, side. But remember, in order to use side, angle, side, you have to have the included angle, which I don't have. It would be this angle and this angle on these two. We do have that postulate from 4.12 that says if we know that two sides are congruent, we can actually say that the other side is congruent. So we could say that triangles in example A are congruent by side, side, side. Okay. When we look at these angles over here, or triangles over here, notice that we have the included angles between the congruent sides. So this one we can technically say they're congruent because of side, angle, side. Okay. Let's see. The practice for this, guys, is pretty straightforward. Honestly, it's not due until tomorrow, but you should be able to get it done in class. You have 10 through 25 all, and you have 33 through 47 odd. Okay, so it's not too bad. You have that. You're on here, and it should be a pretty easy, straightforward lesson. So do that, get it turned into Google Classroom, and we will be done.